So yeah, as I said, I've been working on AI SDK for like close to 3 years now, and been handing it over. And one of the last things I'm doing there is like automating works. I spent July on creating this software factory, and it's a little bit different than the kinds of software factories that you may have seen elsewhere. So I want to walk you through like what we did exactly and how it's different and why we made those choices, right? So why is it even needed? We're using like things like Codex and Cloud Code and all of this every day, right? And so why do we need this additional like factory-like thing? And part of the reason is we couldn't keep up with the issues. We're a team of 5, but the issues just kept piling up, right? There are like new features, new bug reports, like so much coming in, and we also need to like ship the essential features, for example, for AI SDK 7. So there's always this trade-off, like what do you prioritize? How many bugs can you really fix? Which bugs do you fix? And at the end of the day, it just keeps piling up, and you can see like sometimes we clean it out a little bit, but overall the trend goes up. And with pull requests, it got even worse, right? So there's this inflection point in earlier this year, around like January, February, when coding agents really took off, and you can see how the curve bends here, and how many pull requests we get. People don't file issues anymore; they just open a pull request essentially, which I think is not really all that great. And with AI SDK, it's a very structured software, right? But it has pros and cons. So we have these different dimensions, like we have all the different providers, like OpenAI, Anthropic, XAI, and like I think we have like 30 or something, maybe even more at this point. How to keep count? We have to support several UI frameworks. Now there are sandboxes, and we're starting to support more and more sandboxes. And the same happens with coding harnesses, because we now have this AI SDK harness framework, right? And so in all those dimensions, like there are new features that you need to add, new providers that you need to add, bug fixes you need to do. And it just like is a pretty large amount of work because the surface is so large, right? The AI SDK sits at the center that like kind of like combines all those things and makes the interactions between them smooth. So we needed to start automating more work. There was no way with the current team we would get this down, right? And even if we scale up the engineering team, it's just extremely hard to keep up. So the way I approach the factory is to really organize it around smaller tasks that are then run by individual, like either LLM calls or scripts or agents or workspace agents, right? So depending on the task. It is like very different from this idea that, hey, you have a bug report and then you have an agent working on it and here's your pull request and it's all done. We split it up much more, right? We split it up into like, first identify the type, then if it's a bug, reproduce it, create a draft PR with a reproduction. The reproduction has to have like certain characteristics, right? It has to go against live APIs, has to create fixtures, and sometimes you can't reproduce bugs, so then we try to reproduce them, we close them, right? But when we have a reproduction, it's actually like easier to create the fix, and the workspace agent, the bug fix agent could, for example, fix it, and then we have a separate review agent that goes in and again looks at the reproduction, sees if the error actually reproduces, and then like if the fix actually closes the reproduction, right? So it doesn't reproduce anymore. And it does like, of course, like a bunch of other evaluations like security and performance and architecture and so on and so forth, right? And similarly, we have something for feature implementation and also for like docs. But this will be different for every kind of like software system that you have. It's somewhat generic, but also very specific. Now, when you start doing this, you come to a point where you have like, as me, I had like 10, 20 agents running in parallel, right? And so you have 20 issues that you're looking at, like let's say 10 issues you're looking at in parallel, right? So you have like your reproduction agent running on 5, and then some backports going on there, and like another feature that you produce, and a few of them are blocked, and like the results don't, like you need to keep track of it. And the GitHub UI isn't necessarily the best for that. So I started exploring this idea of a custom UI for this, what I call a cockpit, right? That eventually evolved into kind of like even a multiplayer team kind of thing, where like different people can like claim issues. You see the unclaimed issues coming in here. You can claim an issue. That means like you are the person responsible for shepherding the agents through the process, and making sure there are no errors, and like approving the pull request and so forth. And then you go through all those steps. But it's very early, but it's the beginnings of like a UI that's optimized to this new kind of working, where you have a lot of things going on in parallel, and then you need to make decisions, right? My ideal vision for that is over time, kind of like you for example, when you're at the point where you approve the pull request, you get the information that's required for that. More on that later, because I think it's more than just the div and a little bit of context. So yeah, let's walk you through an example of this. This is a very straightforward happy path example. OpenAI introduced a new feature for their web search tool, which is called block domain filter, right? So somebody could say, hey, those domains like you shouldn't search, right? And that's actually a like great feature for this. We implemented this very, very quickly. So like first it gets classified because it comes in, we don't know. It's a feature, high confidence. It does a little bit of research and says, okay, we don't support it in the analysis, right? So feature is not available. Now it's a feature, we analyze it, checks the code base. Oftentimes we already implemented the feature, right? People tend to like file the same thing over and over again, or they couldn't find the documentation. So the first thing a feature agent does is, hey, look, if we have the feature, if we have it, point the user to the documentation, give them all the advice, but then we can just close the issue. But in this case, it wasn't available. And then it does a little bit of like analysis, what the feature would look like. And then also like, does it fit the AI SDK? Because that's the other thing. Oftentimes as an open source project, we get a lot of feature requests that are just not in scope. And so the agent looks also at that. Now that we have a feature analysis, an implementation agent goes in that actually creates a pull request. Again, very straightforward. We have a lot of rules here, like it has to have documentation, updates. It needs to have an end-to-end reproducible example that like derived from a live API, and then created a test fixture and all of that, right? And then the review agent goes in and looks at all of that and says, okay, I approve it. And then it looks at different aspects of it. Is the feature actually implemented? Because sometimes, you know, those coding agents, they don't fully implement the feature for some reasons, right? Does it have any unexpected side effects? Is the performance okay? And then there are like 8 other categories. And then like with all this information we can look at, like we look at the diff, this information, the process, and of course the GitHub checks, which are test suites and linters and so forth. And then it gets merged. And then since it's a small feature, we now also have automatic agents for backporting. Before we had a script that did a little bit of the backporting, but as soon as you run into merge conflicts, which you do at a certain point pretty often, the script couldn't resolve them. And now we have agents that like, they try to merge. If it's clean, it's great. If it's not clean, they try to resolve the merge conflicts. If that's not straightforward, they look into re-implementing the feature for the branch or the bug fix. Okay, don't get too hung up on this slide. There's a rough overview of the deployment. In what I'm building out, a lot of this is changing. So you could also use workflows versus workflows or Eve for some part of those things. But overall, there is a UI, there's a web app, there's an underlying API, there's an execution space, there are sandboxes, and then we also have a full synchronization for GitHub that allows us to automatically trigger some stuff. So for example, an issue comes in and we fully automatically run parts of the previous pipeline, right? So for example, like it gets classified as a bug automatically, then like the bug reproduction automatically kicks off. If there's a reproduction, bug fix already automatically kicks off. If a bug fix is available, review automatically kicks off and so forth. Yeah, so that's a rough architecture. Nothing surprising here. So how did that work out? So here are our total issues, and you can see like they're growing. And here we hit the high water mark, right? This is what I showed before. And since then, they've been decreasing. And a lot of it with the help of the factory, as you see here, like the number of factory closed issues. So that includes both the ones that got like where code changes were necessary, and also the ones where code changes were not necessary, right? Where a bug could not be reproduced. Maybe it has been fixed since, maybe the report was invalid, or the feature is already there. But overall, we like managed to be around like above 75%. Now, we had a lot of old issues, so I expect this number to come down a little bit. But overall, I think it's a huge support for the team, and it's also what they said. And you can see it here. This is more the impact on what's being merged. It's around 30-35% on main. But for AI SDK, we have to support v6 and v5, so we have many branches. And usually backports were a little bit of an issue because, again, when there are merge conflicts, right, and then you need to manually resolve them, where do you really invest your time? Do you invest your time in the backboard, or do you invest your time into fixing something else or implementing something else on the main line? Right. And so with this automation, we're now actually capable, like in the position where we can backport much more, which is great because it means that we can be much better at the maintenance of these older branches. All right, so that's the case study, and now I'll go into my thoughts on all of this. Let me actually check quickly on the time. We have plenty of time, so that's great. So the first thought I have is that software factories must fit the project, and that's a little bit different from like other software factories that you may see, where they are like a SaaS or fully automatic, right? I think like each project has like different workflows, right? That are and processes that are established. It's like what comes in, which tools do you use? Do you use Linear? Do you use GitHub for issue tracking? Do you use Jira? What do you use, and what are your steps? And what kinds of issues do you have, right? And what's automatic, and where does the team meet, and so forth. And then projects, like real world projects, they tend to be complex, right? They're not the toy projects that you just one shot with Fable. It's like they have a considerably large code base. Sometimes they go by multiple repositories, right? They're not necessarily monorepo, especially if you have a service-based architecture. There are dependencies that have to be taken into account between services, between library versions, other things you install, right? And then not every company has this, but there can be, like for open source project, different release branches, or if you're an enterprise software company, right, you have different releases that you need to maintain, and maybe there are modifications for particular customers, and so on and so forth. So it does get complex. There is the software architecture, which I think is super interesting in the age of agents, but there are pre-established patterns that need to be followed, right? Boundaries, interfaces, and you need to somehow make the agents follow them. Then projects have different quality bars, right? For some projects, like if you have your personal coding projects, you don't even like necessarily look at the code. I vibe code like some personal things on my VPS that I then can just use. I don't look at the code. If there's a bug, I tell the agent to fix it. But if you're on the other end of the spectrum, like work on a pacemaker, like you can't do that. Right, and most projects fall somewhere in the middle, where like with the AI SDK, I think we're a little bit more on the thorough side. Other projects may be a little bit more on the lenient side, but at the end of the day, every project has a quality bar that needs to be met. And finally, the automation boundaries, right? They change over time, and like again, like it's part of the processes. You already have this. You have automatic linters that run, and maybe they run in CI. You have automatic testing that runs at which stages, and so on and so forth, right? And now the agents come in there too. Like what do you hand off to the agent? What gets handed back? So I feel like every project is unique in a way, and so the factories must fit the project. So that's one. And then when you think about the agents, they work on a spectrum, right? So that's important to keep in mind. If you have something like Codex or Cloud Code or Pi or whatever, right? It's very steerable. Right? It's interactive. I call it an interactive coding agent, where you go in and they work on your code base, and you give them an informal prompt, and then you talk to them and you guide them to a certain solution, and you look at the solution, and then you create a pull request, right? So it's very private, it's interruptible, it's informal. On the other hand of the spectrum, and I think this is also true in a way for projects, right? This gets much more formal. The AI SDK Factory is formal, right? It's like event and policy triggered. So for example, like a new issue comes in, or issue gets a certain label or something, and then something kicks off that's running in the background where you don't necessarily interact, right? And it's very standardized. The prompts and everything are standardized by the project, by the maintainers. And there's not this interaction, but it's also a shareable public record of what happens, right? If you do like your local agent sessions and then create a pull request, a lot of the details get lost. And in a way, like actually those AI SDK Factory agents, they give you less flexibility and detail as one person, but they create more auditable artifacts for public or team visibility, right? So it's all a little bit more formal, which has pros and cons. And by the way, we use both, right? So in the factory, like only a certain task is well amenable to automation. Other tasks we mark as manual, and then we go back into the steering mode. And it depends very much on the area of the code base, and the kind of feature or thing you're doing, right? One thing I've been thinking about a lot recently is the need for architecture and how architecture is changing in the age of coding agents. So it used to be you have a software architecture, and your software provides certain things to accelerate manual coding, right? Structures your space, structures how you think about it, but it also gives you things that you do not have to re-implement. Now with coding agents, like just creating the code has become cheap. But you could imagine a coding agent going off on a task can have many different ways of approaching it, and not all of them may be good and acceptable within the thing you're building, right? So the way I think about architectures is it's constraining the solution space, right? If you have a strong architecture, there are only so many ways how a coding agent can solve a certain task. And now AI SDK is very structured, right? For example, we have those providers, and they have a very standardized way of testing. They have a clear interface, right? It's a provider API to our specification. There are like many examples, and that is super well suited to factory style automation, where you, with the right prompt that you set once, then can like solve a whole class of issues very automatically, right? In non-interactive way. Okay, another thought. Human review is becoming the bottleneck, right? We're not coding all that much anymore, but it takes time to understand what the agents are doing, what they are producing. And if you just look at like the summary in the pull request div, it takes a lot of time sometimes. So two thoughts on that. One is, how much review does a change even need? And I think that depends on many factors, right? It depends on the size and complexity of a change. It's easy to review, of course, a few line diff versus 1,000-line diff, but it also depends on the type of change, right? If you have a simple bug fix, that can be much easier to review than a bug fix where, like, for example, it's not always reproducible. It's one of those flakiness things, right? And similarly, a feature like I showed before that's limited to a certain provider in the AI SDK world is easier to review than necessarily like a cross-cutting feature that touches the heart of the AI SDK, where you have to think through much more, right? Kind of related are the areas that are affected. So depending on what is touched in the code base, it may be easy, it may be harder to review. And two other things that I think are important is whether the change is easily reversible. So for AI SDK, it's something like, if we change our public APIs, we can't easily reverse this. It's going to be like breaking for so many users. So those changes need much closer review than, say, an internal fix that has no API surface impact, right? Yeah, related to that is potential impact. Like if this goes wrong, if this doesn't work, like how bad is it going to be, right? Also always important. And depending on those factors, like you want to review more or less closely. And so now what goes into the actual review, what gives you confidence, right? And I don't think it's just the final code change, the div. It's also like, of course, all your automation that you have set up, right? The test lint, the type checks, every project has that today. But I think what's interesting is the recorded process. So you saw before I split the bug fix process into 3 separate agents, right? That are isolated. The first one reproduces the bug, the second one fixes the bug, and the third one reviews the bug according to certain criteria. With that process, I can already assume that there was a successful bug reproduction, right? Because that happens against the live API, and also the review agent actually also reviewed the reproduction, right? So through the nature of the process, I can already kind of like check off one thing that I would have to typically worry about as a reviewer. And I think there are many more like that. Then I think this is interesting because I think there's a lot that can be improved here. You don't just review the div and maybe the summary. You review all the comments. You review the analysis that the review agent provides you, right? You take a quick look at the checks. So there's like many artifacts that come together that accelerate your review and that you take into account. And there's also, and I think this is one of the reasons why I wanted to build the factory, the past agent performance and the fact that you control the agent, right? So we had the problem that, as I showed you, like we are over 1,000 pull requests, open pull requests now, right? Because anybody from the community can open a pull request, which is great. But the problem is we do not know their prompts. We do not know their agent, right? And so how much trust can we have? If we have a very specific agent with a very specific prompt that we optimized and where we know that over history, this was very successful in fixing a certain category of bugs, right? Then we kind of develop trust in that particular agent configuration. And I think that's what for me falls under past agent performance, and that's why I think necessarily for open source projects, like it's worth considering having your own agents, own setup, and not necessarily trusting the community, because it can actually cut down your time to review. So some examples here, like and this is the idea of like how much does something even need reviewing, right? So docs change, low risk, and a lot of evidence is already provided, it's reversible and so forth, so little reviews needed, right? Another case I showed for a well-defined provider API change, right? So that has some moderate risk, but through everything like the past performance and everything we set up, we have really good evidence that this works. So again, the review load is not too high. Take something like new user-facing functionality. Here there may be like steering and human development needed, right? And it's a high-risk thing, and not much evidence comes in. So we need to spend a lot of time reviewing, right? And all this, like in my mind, goes to show that, like with the right structure, you can like reduce this review bottleneck. Okay, on to something else, the factory engineering loop. So when you start building these factories, right? Factory like engineering becomes part of the job in a way, because the factory will only cover so much, and it'll like we specifically introduced it incrementally. So we start with something small, and then over time we increase the scope of the factory, right? And every little step provides value. For us, the first step was issue classification, and that provided value, and then we built from there, right? And so when you run the factory, you'll notice it doesn't always work. Like sometimes it works, so you can ship the result, great. But sometimes the result is flawed, right? So what do you do with that? First, you can't let it through. You have to map it. And then you can think like, okay, you do it manually for now, maybe. You improve the prompts. You maybe like there are some other things that you can improve to guide the agents better, like maybe new lints, maybe better documentation, right? But something needs to change, or you need to do it manually. So these are critical in increasing the scope of the factory, of what the factory can handle. And the same for blocked ones. Blocked, I mean, to give you a few examples where a factory would be blocked, right? A live reproduction needs an API key, and you don't have this set up in your automation environment, so you need to add that. So otherwise, you can't get live reproductions, right? Another one is security issues. So we had this issue where like we have a few security things, and I wanted to have a bug reproduction, and then we tried doing that, and OpenAI said there's a cybersecurity risk. I'm sorry, I can't help you. So you wouldn't even let us reproduce those bugs, right? So then you need like OpenAI cyber access or a model that can work on cybersecurity issues, right? And other things maybe that like a certain environment that you need is not available. So for example, a Docker container with Windows or something. And all those things you can take to improve the factory with the goal of increasing the scope, what it can handle, right? So you would go through the logs and you would look at, hey, where's the factory failing? Like what's not working? Improve that so we can like increase our automation coverage. And I think this loop will become pretty essential when you start building factories. Okay, now security. Security is critical these days. And we all hear about security issues to like cyber offensive attacks by agent groups. It is already a huge issue. It will become an even bigger issue. And with open source projects specifically, you have the problem of community controlled content, right? So in particular, the issues, the PRs, the comments, or even the links they send us, right? The docs, all of this could have prompt injection attacks. And we're a juicy target, right? To get a malicious code change into the AI SDK, that would be very nice because you could infect a lot of people. And then there are like some other things, like you could try supply chain attacks, right? Introducing some dependencies. You could just want to spend our money by like getting 100 issues and like just wasting our money. You could try to exfiltrate our API keys or prompts to reproduce the factory and so on and so forth, right? So it is a juicy target, it's a software factory, especially for an open source project. And there is the surface where we have the input that can attack it, right? So we have like several layers of security that we introduced to give you, but I think there's more to come in the future. So for example, like we filter everything invisible from comments or PRs, right? You can somebody could just have like those comments in the GitHub. I'm not sure if you've seen them, but the comments that you don't see, and try to introduce content like that. We filter all of that out. But that's obviously not a one like fits all solution. What you really want is defense in depth, which as many security like fences as possible. So another one we have is like inside the sandbox, we split different roles, right? The sandbox is controlled by the outside, by the way. So the agent runs outside the sandbox and only executes the tools inside the sandbox, but it executes them in a agent user, and the agent user does not have access to any API key, right? It goes to an internal proxy, which is run by a different user, the harness user, and that would rewrite certain requests to inject API keys, right? So to, for example, deal with API key exfiltration to a certain degree, right? But there's of course more. You need like monitoring setups and yeah. I just want to point out that with software factories, you get a very new security angle.